Welcome to Rational Functions, and we're going to look at vertical asymptotes and or points of discontinuity. This is part one. First of all, what do we mean by rational functions? What are we talking about? Well, we're talking about these guys where you have a polynomial on the top and a polynomial on the bottom. Okay? So we've looked at these before. These are what they call rational functions, and we know that vertical asymptotes, typically, they appear when you try to make this, the bottom, the denominator, 0. That's usually where vertical asymptotes appear. So this is what we're going to focus on, g of x. So basically the rule is determine your non-permissibles, and those could be, so I'm going to say could be, either a vertical asymptote, or it could be a point of discontinuity, which often is referred to as a hole. Okay, it's kind of like just a little hole in the graph. So there's two things that can happen when your denominator here turns to 0 at those locations. So the question is, how do we know which is which? So we're going to examine that. So I'm going to clear off this little screen, and with the help of a graphing calculator, actually, I went ahead and I graphed the following function. Okay, so on the top was x plus 3, and on the bottom I had x minus 2 times x plus 4. And you notice this is in the factored form. It makes it much easier to identify these if it's already factored for us. So there are two non-permissible locations. There is x is 2, and there's x is negative 4. Now, with the help of a graphing calculator, it turns out the graph looks actually, why don't I use this line draw thing, and I'll just give you a rough idea what that graph looks like. And of course, using technology makes it really easy, because you can just look at the picture and you can say, hey, at negative 4, turns out there is a vertical asymptote now. Okay, and at positive 2 here, there is also a vertical asymptote. Well, how did we get so lucky? Okay, how do we know that? Well, because when I graphed it, it looks kind of like this. There is an x-intercept, by the way, at negative 3. Negative 3 is what turns the top into 0, so that's the only x-intercept. And then the graph did this on my graphing calculator. It came roaring like that, and then it goes roaring down. So that's what that part of the graph looked like. And then over here, it kind of did this. Okay, and so not only did we have a clear couple of vertical asymptotes, but also it seems like there's a horizontal asymptote here, but that's for future lessons. So, we look at this function and we go, well, these turned out to be vertical asymptotes. So I wonder how we know that, especially since if I now graph the following. Suppose I graphed this, x plus 2 times x minus 2 on the top. And on the bottom, say I have x plus 2. Okay, what if I said go ahead and graph that? I mean, you would start off and say, well, there's definitely at negative 2 something happening. Okay, something's going on. I think maybe a vertical asymptote. But it turns out when I graph this one, let's see, maybe I can squeeze it in on the side. And again, I cheated and I used a graphing calculator. Okay. So let's say I went ahead and I graphed this guy. What did I get? Let's see. I'm just going to mark things off here. This is negative 2. I actually got what looks like a straight line. And indeed it is, with one exception. It's kind of a straight line. Let's do a decent job. We went through there. And I can't squeeze it on my graph here, but actually at -2, way down here, there's a hole in the graph. So sorry, it's off the screen here. But what we would do is, and I'll just show you a little higher, we would mark that with an open circle, and that would indicate that there's actually a rip. But the line actually kept going. On my calculator, it's really hard to spot those little holes. It does that, okay? But otherwise, there's clearly no vertical asymptote. So how do we know? How do we know which it is? Well, it's actually really easy to spot. If you look at this, there's something I can do with this function that I couldn't do up here with this function. That's right, I hear you screaming it. You can cancel. See, I can just cancel this off. And so it's not really surprising that we got a line, because look at what's left. We got y equals x minus 2, which looks an awful lot like a linear equation. It looks like a line with a slope of 1 and a y-intercept of -2. And that's exactly what this graph is, with one exception. There's a hole when x is -2. Now, how do I know exactly where the hole is? Because if I tried to plug -2 in, once I've done my simplifying, I could. Here it works fine. See, in the original it doesn't work, but here it would work, and so that kind of tells us the location of the hole. -2 minus 2 is -4. So if you just go ahead and you plug in the location of the point of discontinuity, then you can figure out the y-coordinate of that point of discontinuity. So I know exactly where it is. See, there's a little hole right there in the line. That's actually off my screen here, but it doesn't really matter. So that's how you know the difference. If you cannot cancel, then you're going to deal with vertical asymptotes. Okay, but if you can cancel and simplify, then you know it's just a little tear, as it were, in the graph. Okay, so that's kind of where we're at, and I'm going to come back and do an example because I don't want this to drag on too long. So I'm going to stop.